So for my TOK finale, I began by comparing my approach toward grappling with the existential question of why am I here, uh, and what am I here for, uh, with another question, and that's how I approach analyzing my own teaching and assessing how I could improve. And I began to explore how my approaches toward those two different questions were similar and different. Uh, but I was just getting the sense that it was just another TOK presentation, and it wasn't giving me the sense of closure from the course that I wanted. So I've changed my topic, and today I'd like to discuss the role that the IB's model for TOK helped me play, or played in helping me come to understand uh, how I construct my understanding of reality. And the reason why stems from my work in the first trimester. I was looking through everything I'd done over the course of the year to try to get closure. And I think probably the most fun part of the year was writing that diatribe denouncing the IB for presenting us with this citationless, utterly preposterous model that I could already poke a million holes in through math, and just forcing us to do all analysis in terms of it. So I wrote a lengthy diatribe on the AOK exploration, explaining some of the holes I could poke in it, and I'll get into that in a minute. But in any case, I was extremely reluctant at the beginning of the year to even entertain the model, given I could poke so many holes in it. And yet, over the course of the year, I found it has helped me to some extent come to understand how I learn. So originally, I thought it was going to be somehow the most useless thing ever, given I could already find flaws, and it ended up helping me anyway, even though I still think there are flaws in the model. So I'm going to discuss that disparity and how I think, why I think the model was able to help me, even though I could still identify flaws, and even though the model is objectively imperfect and probably will never be perfect. So for that AOK exploration, it was really my first immersion in the TOK program. The campus walks were fun, but I didn't have much. I didn't have much of an investment in them, in that the topics were kind of mundane to me. Like, I can explain why I think the fire hydrant on Lakeside's building side, whatever, outside is yellow, but how much do I really care about how I came to know that? Personally, not much, for better or worse. But the AOK exploration was different in that I chose to do it on math, which is meaningful to me in that I co-teach a calc class, and I've been taking math for years, and I've really enjoyed it, and at the time, and still now to some extent, I think it's a significant influence on how I come to understand reality, just given that I engage in that sort of logical thought for so much of my day and for so much time. I've had practice with it. So it was really the first time I felt invested in using TOK to come to understand something meaningful about how I and others learn. And for that reason, I didn't want to let up as much as I may have been willing to compromise for the campus walks. So I began my analysis. I was talking about math and how we came to understand it, and I started thinking about the structure of mathematics first. And I discussed, it came out okay first. I was talking about pretty generically the WOKs that we use in math, like language, intuition, reason. Those were the three I used, I think. But I discussed the role they played in math, and all was well and swell because they were meaningful in math, and I can argue why for each of them easily. But as I tried to support these to explain them more clearly why I thought that to others, I encountered a bit of a problem in that I was trying to find concrete examples of how each of the WOKs came into play, and I realized that the examples, well, first, since it was the mathematics AOK, I looked back at the IB's definitions for everything, because that's what made sense. And for mathematics, I began talking about geometry. I spoke of someone entered the room and I had to take a break. So the examples I was using and the ones that were coming to mind first were the ones I had the most experience with, in general, dealing with math. So I brought up calculus, I think I brought up imaginary numbers, I was talking about geometry a bit, and formal logic, like mathematical logic that was formalized. And it occurred to me, hold on, if I'm talking about mathematics as this system of ideas, where we assume certain statements called postulates and use reason and, among other things, to get to theorems, and then math is these ideas and the interrelations between, those aren't limited to geometry, calculus, and all those fields. It didn't make any sense. If math is the AOK, that encompasses the way of thinking that I defined as math with this sort of system, this notion of postulates and theorems and everything between them, then there was no reason why the AOK of math should be limited to these topics of geometry and whatnot that the IB was defining as relevant to them. So it confused me a bit, and I wrote a whole diatribe about that, because it didn't make sense to me. Mathematics, as I thought, was this style of thought involving this certain synthesis of intuition, reason, and language, among other things, and that's what defined mathematics, not these mundane topics that we happen to be applying it to. I'll get into how that perception evolved over time, but first I'd like to speak about a couple other models that have helped me learn, and then I'll bring it all together to make my point. So the same happened with the natural sciences for me. I was thinking about how I distinguish natural sciences as an AOK from the rest, and it occurred to me that the IB's TOK model doesn't recognize some distinctions too that I think are important. So like the topics that are commonly associated with natural sciences, so physics, chemistry, bio, things like that, are the topics that the IB kind of saw as falling into and are commonly perceived as falling into the realm of the natural sciences AOK, if we want to call it that. And that's fine, but to me, reflecting upon my experiences with natural sciences, and research in particular, scientific research, it's not these specific topics that are important to what makes science science. It's a certain branch of thought. All these topics happen to be unified, that we generally approach them with the scientific method, where we have this belief called a hypothesis, and we use certain procedures that are logical, often involving reason, to test them with empirical evidence and observations, quantitative or qualitative, and wind up with a set of conclusions, and that we're aware of the limitations of. It was more this style of thinking that I thought distinguished science or natural sciences from other AOKs, not the topics that it happened to cover. But that kind of violated the IB's model just like math did, in that scientific thought with reason seems a lot more like what the IB would classify as a WOK than an AOK. So the distinction between the two with the model in both math and natural sciences just didn't make any sense to me whatsoever. I completely rejected it. And for that, and I didn't even want to separate AOKs. So if this way of thought, like one could think, okay, well, natural sciences, we're just using math to test data, right? So that's just kind of the same thing as mathematical thinking. So if we can't distinguish between an AOK and its WOKs, and now we can't even distinguish between an AOK and another AOK, so what's the point of all this nonsense? Why should I be exploring this model? That was my view on TOK for the first while. So other models I've used, I was thinking about it, and it's not the only model that I've ended up entertaining that was far more simplistic than reality turned out to be. So for instance, when I was learning about how light behaved, in middle school I was taught light is a particle. It comes through this thing called a photon. And it justified a lot of what light did to me. So like reflection. Okay, well, if I've got a photon hitting a mirror, it's going to be reflected at the same angle, comes back off, makes sense with the particle model. It also explained why light exerts a force on other things and whatnot. And for my understanding of light at the time, this model of light being a particle, a photon, made sense to me. It justified my understanding. And it made things clearer. It just made it easier to understand and gave me terms to express what I needed to. Come high school, I show up in Miss Stone's chemistry class, and what do you know? If you take a double slit experiment, or the setup for it rather, and put a little bit of light through, it turns out that it does not behave anything like small particles behave. It behaves kind of like a wave. And it made me uncomfortable because it violated the previous model. And I was like, okay, well, why did my teacher teach me that it was a particle then? That doesn't make any sense because clearly that model doesn't apply. And yet, in hindsight, it was important that I understood it in terms of that model first, because it was only my understanding of light as a particle that allowed me to realize why the model didn't fit and evolve into, well, as my understanding evolved, my model evolved too. I came to realize, okay, well, there's this thing called the wave-particle duality that people use to understand light. And as my understanding of the concept improved, the model I used for the concept improved. So even though the first model wasn't capturing all of the technicality that the concept required, just like in math, the IB's model didn't capture the thought I thought it did in all its complexity. Even though the light model wasn't sufficient initially with photons, it was the bridge that allowed me to reach the more sophisticated understanding and the more sophisticated model that came with it, that ultimately improved my understanding of light. The same goes for in scientific research. Like when we do research, we gather a bunch of data to try to figure out whether a hypothesis or not is true. And that's great. But we're not going to look at every single data point and go through everything. That's insane, and we're going to have outliers, stuff like that. So of course we're going to use some sort of a statistical model that simplifies the complexity of all this data in an effort to draw a conclusion. And science is, one of the nice things about science is we recognize explicitly the limitations of that model. For instance, when we find a correlation, we find something called the R-squared value, which explains how good the correlation, how effectively the correlation fits the nuance in the data. And that allows us to see both the limitations of the conclusions we draw, how confident we can be about them, whatnot. But ultimately, without having that model that may oversimplify some of the nuance in the data, we would have no way to even begin to approach a spreadsheet of data in the first place. So even though the model is a bit simpler and has limitations that the raw data themselves may not exhibit to as great an extent, it's that process of simplifying reality into a model that lets us draw conclusions about reality in the first place. And we can improve the model over time. I mean, like with gravity, first we thought that gravity was just 10 meters per second downward, and then someone did a better experiment that resulted in a better, more nuanced model that it's 9.81 meters per second squared is the acceleration due to gravity. But the point is we keep improving our models as we keep improving our understanding of a given concept. And that's what happened in natural science. That's what happens in nearly every case with models. And the model continues to improve over time, as does our understanding. But we have to accept some first model to be able to draw conclusions in the first place, to allow us even to begin analysis of how complex reality is. And we improve the model over time to hopefully resemble more closely that true complexity. So back in terms of TOK, I had this model that just seemed utterly preposterous to me because it didn't suit the complexity of reality as I understood it. And over time, entertaining the model, even though it was imperfect, helped me figure out how I do understand reality. So for instance, during the TOK essay, I was speaking of mathematics again, and I spoke of, in particular, why disagreement is central to mathematics. And I was speaking about the role of intuition and reason as isolated processes. And ultimately, I think the reason the model helped me there, the reason the model was effective in argument, was that I wasn't trying to come up with a whole model that represented knowledge. I mean, it would always be imperfect, as good as we can make it and as much as we can improve it. I was using the model to make a specific argument, and that made it a bit easier for me. Because the model didn't have to capture all of the nuance of reality to allow me to draw a conclusion. So that was one way in which the TOK model proved useful, even though I was so ready to dismiss it. In other words, the model should be a means to an end, not the end itself. The model helps us come to better understand reality, because there's no model that can ever be sufficiently complex. Well, no, I don't want to say no model, but it's difficult to come up with a model that sufficiently encapsulates all the complexity of reality. So it's just a vehicle to help us understand and reach an understanding of the complexity of reality and try to approach that. The same thing happened with my TOK essay when I was discussing the arts. Because of the TOK model, the TOK model accentuated the difference that might not have been as apparent otherwise. Apologies, part 2, my computer just froze. as I was discussing the arts in my TOK essay, the TOK model accentuated the difference that might not have been quite so apparent to me otherwise. There were two analysts trying to authenticate a Greek statue that the Getty Museum was buying, and one of them used strategies that I think would clearly fall into the reason denomination within the AOK, or within the AOK of natural sciences, in that they were using scientific techniques like chemical analysis and stuff like that to authenticate the statue, whereas the other analyst was able to flat out call the statue as inauthentic because he couldn't reconcile it with his intuition, the whole of his personal knowledge in the area previously. And in this case, the WOKs were more discrete than they probably are in real life. For instance, like in this analysis, I was separating clearly these two WOKs, whereas in something like math, we can clearly see, okay, well, maybe they don't operate as much in isolation as they seem to. Like intuition lets us come up with postulates, which are the bridges to the reason we need to come up with theorems. And in reality, they're probably interrelated in terms of the Getty too, but it's just, I didn't get into that as much. Still, in any case, having the model to start out from allowed me to begin to approach the topic and have some direction with which to begin my analysis. And it would get more complicated, I'm sure, as I'm speaking of now, if I continued the analysis and continued to identify flaws in the model. But the point is, using this imperfect model helped me come to understand reality better than I did before. And the model improves over time as my understanding improves over time. Finally, the same thing happened with my TOK presentation. I was talking about how explicit explanations need to be considered satisfactory and to persuade someone that some piece of knowledge is true. And I was comparing the role certain WOKs had between literary arts and scientific research. My stimulus was teaching, but I've gotten into that already in this video. In any case, I was comparing the role that reason and intuition may have served as a focus in the scientific research field in comparison to the role that intuition and emotion play in literature. And it's not that, again, it's not that they don't overlap. It's just using this model helped me begin to analyze the phenomena that were taking place. Again, further analysis may have led me to draw the conclusions that, again, the model wasn't as clean-fitting as it seemed to be, just like I was able to figure out with mathematics. But having the model in the first place is what enabled me to do the analysis that I did. And that's worth something because it helped me come to understand something better, even if I still can't understand the completely complex reality that exists. So, in conclusion, a model is useful because it provides a starting point for understanding reality. It's not perfect, just like the TOK model isn't perfect. And yet, the TOK model, despite its imperfection and my resentment toward all of its assumptions that I could totally argue against even from the beginning of the year, when it comes down to it, it was still that model, just as many other models have done, that helped me come to better understand a concept. And I applied it in a bunch of different ways that ended up being really interesting and improving my understanding of how I and others learn. It's nice to be able to start with some model for that reason, even if it's imperfect, and that's the role that TOK served for me. However, when we keep exploring things further, we often come to identify flaws in the models, and that's okay, because that means, just like with light, when we realize that, okay, something's funny with this double slit experiment, you improve the model more and more over time as your understanding improves. They're paired together, and you just reach a better and better understanding of the complexity that reality is. Models are the way that we make sense of reality, and with the TOK model, I entertained a model that I knew was flawed, because it was doing that allowed me to begin my analysis, that helped me better understand reality. And if I tried to make my own model for TOK now, it still wouldn't be perfect. No one can go through all possible analysis, because reality is infinitely complex. Not infinitely necessarily, but it's really complex, and you can't encompass all of that with the model necessarily. And that's why we need to accept models that aren't perfect, even if we know they aren't perfect. It's what we do in science. It's what I did in TOK. and it's the only way we can even begin to explore a subject. And it improves with time, and so it goes, but we need to be willing sometimes to accept and entertain a model that's not perfect, just for the sake of beginning analysis and making sense of things, with the knowledge that we'll be aware of its limitations and improve it over time. So, in conclusion, my remark at the beginning of the year was the person who wrote the TOK syllabus ever told no by anyone at all in the process? This course could be such an incredible opportunity to try to form our own models of knowledge in its construction. And although the process would probably fail for all of us, as I think it did for the IB, at least we would get to explore how we know what we know in the process, which is the goal of the course. Yes, I was right. The person who wrote the TOK syllabus probably was never told no by anyone you should cite things. No, I'm kidding. And the course probably would have been interesting if we did try to form our own models for knowledge. But even though this model wasn't perfect, and even though I could identify flaws in it, it was only the fact that I was willing to entertain it that allowed me to conduct the further analysis I did later on. And I think that's what I've learned from TOK. I've learned that when a model or when things in general of an understanding aren't perfect, you've got to start somewhere and you improve it over time, and so it goes. You can't just utterly reject something because it's not perfect in every single regard you can perceive. And it sucks being a perfectionist, knowing that I have to entertain a model that's imperfect, and that's why I had so much trouble starting TOK at the beginning of the year. But I think once we come to terms with that, it allows us to understand reality with greater complexity, and we improve the model as we go. That's how we learn. So it's been an interesting year, and I think that's the main way in which I've grown. Thank you.